Hi guys, this lesson is on composition of functions, and this is something, this composition that we're going to be looking at is something that is really a fancy way of looking at substitution. And you probably remember doing substitution back when you did linear equations, where you were doing like substitution or elimination to figure out where the two lines crossed. But here we're going to be using function notation, and we're going to be using things that are lots of different shapes, not just lines. The first thing we want to look at are that there are two types of notation, and one is this over here on the left, where we have f of g of x. It's read of g of x. And I like this notation because you can see that the g of x, the function notation named g, is inside of f. And so that is showing you that you are substituting g into the f equation. Another type of notation is this FOG. Now this O is probably a little bigger than I would like. The problems that you'll see in a textbook or in a printed something else, it's gonna be a little bit smaller, but it is gonna be like an open little O, but you read it F of G, and you're always plugging the second thing into the first. So we're substituting G into F. Now we can use lots of different letters. We can have F, we can have G, we can have H, M, P, whatever. You could plug F of F if you wanted to, or G of G, but it's just versions of substitution. So in example 1, we have f of x is negative 9x plus 3, and g of x is x to the fourth. And if we want to do f of g, reading this direction over here, I am plugging g into f. So I'm going to plug x to the fourth into the f equation in place of the x. So this is what it would look like. I would have that f equation, but where the x would normally be, I'm going to put x to the fourth in. Now, all you have to do is decide if you want to simplify or if you can simplify. And here, because I have a negative 9 in front of this parentheses, I can think about distributing it in, but there's only one thing it goes to. So you're just looking at that really as negative 9x to the fourth. And so this just is as most simplified it can get, as it can get, negative 9x to the fourth plus 3. All right, example 2, we have f of x is 2x minus 5, and g of x is x plus 2. In this one, we really have two problems. One, we're doing f of g of x, and the other, we're doing g of f of x. So let's look at the first one. Okay, same order that we've been doing, so we're plugging g into f, okay, the second into the first. So this time g is x plus 2. I'm going to be plugging that in to the x in this equation over here. So when I put that in, I'm going to put it in parentheses. So it's going to be a 2 and then a parentheses with the x plus 2 in it minus 5. So you'll notice how it looks like the f equation, but the x has been replaced with the x plus 2. Now, to simplify, I have a 2 out front, so I'll need to distribute that in. So I'll do 2 times x and 2 times 2. So that gives me 2x plus 4, and then I have the minus 5. And now I can combine the 4 and the negative 5 and get a negative 1. So this will be 2x minus 1. The second problem, g of f, reverses the order of the letters, but that is also reversing what's being plugged in. So f is being plugged into g. I'm going to take 2x minus 5 and put it in for the x over here in the g equation. I'm still going to put it in parentheses because I always do that just in case. Now once you have it written down like this, I can then think, do I have anything out front to distribute? And I don't in this case. And I don't have any powers or anything to worry about. So I can really drop the parentheses and go ahead and combine the negative 5 and 2. So that will give me 2x minus 3. Example 3. I have f of x is x squared plus 7, and g of x is x minus 3. Again, we want to do f of g of x and g of f of x. Okay, so this one's a little bit different because of this x squared, and you'll see how it affects it in just a minute. So looking at the first problem here, f of g, I'm taking g and substituting it into f. So I have x minus 3 going into the x over here. Now, pay attention. When I write that in, I'm keeping it in parentheses. The squared is still there. The only thing I've done is replace the x. But everything else looks like the original f equation. Now, if you will remember, when you have something like x plus or minus a number in parentheses to a power, to a square, in fact, that means I've got to write it twice. That helps me remember to FOIL and or double distribute, whatever you call it, and get all of the pieces that I need. So I'm going to do x times x times negative 3 times x, and negative 3 times negative 3. So when I do that, I get x squared minus 3x plus 9, and I bring down that 7. My last step would be to combine like terms, so I can combine the negative 3x's and get a negative 6x, and combine the 9 and 7 and get a 16. Okay, and that would be that first problem. It's as far as I can go. Now, the second one, g of f of x, I'm plugging f into the g. So I'm plugging x squared plus 7 into the x over here that's subtracting 3. So I'm putting that in place of the x. And again, I have a parentheses, but I look in front. I don't have anything to distribute. And this time I don't have any powers outside, so I can drop the parentheses and go ahead and combine the 7 and the negative 3. So I get x squared plus 4. All right, in example 4, I'm using the other notation with the parentheses. So f of x is x minus 1, and g of x is x squared plus 2x minus 8. I chose this problem not only because of the other notation, but also because g has 2 x's. So if I'm going to do g of f, I'm plugging f into g. That means I'm taking x minus 1 and plugging it in to both of these x's. So it's going to go in for both of them. So I have that one squared plus 2 times the x minus 1 again. So it fits with the g equation, but the x's have both been replaced. Now, when you're looking at this, the first one is squared. That's one where I'm going to have to write it twice. And then the next one is just one where I have to distribute in the 2. I can do that in the next step. So I write that first one out, x minus 1 times x minus 1, but I'm going ahead and distributing 2 times x is 2x, and 2 times negative 1 is negative 2. And I'm bringing down the negative 8. Now I want to FOIL again or double distribute these first two. So I'm going to do x times x and get x squared, x times negative 1 and get negative x, negative 1 times x and get negative x, and negative 1 times negative 1 and get a positive 1. So I get all of those, and then I bring down what I had, and now I want to combine like terms. So I have the x squared. If you look at the x's, I have a negative x, that's a negative 2x right there. But over here I have a positive 2x, so my x's will cancel out. They go to 0. If I combine 1 and negative 2 and negative 8, I'm going to get a negative 9. So I end up with x squared minus 9. And I can stop right there. Alright, example 5. So this one's going to look a little different. I have f is 4x plus 3 and g is x squared. This time we will f of g of 2 and g of f of negative 1. So this is a little different because we have numbers. And there's two ways to look at it. I'm going to show you the first way, but I really like the second way, and I stick with the second way most of the time. The first way is to figure out what f of g of x would be, the equation. And so if I treated it like f of g of x, and I plugged the g equation into the f equation, then I could plug in the 2, and 2 squared would be 4, and 4 times 4 is 16, and I would get 19. Now, that works, and if you like that, you're welcome to do it. But I prefer this next method. I like to take 2, plug it into g, get an answer, and take that answer and plug it into f. So the first step in my second way here is to plug 2 into g. So I'm going to say that that is g of 2. Well, when I plug 2 in, I get 2 squared, which is 4. And then my next step is to take that answer and plug it into f. So I'm figuring out what f of 4 is. So I'm plugging 4 times 4 plus 3. And obviously 4 times 4 is 16, and 16 plus 3 is 19. You'll notice these last few steps are the same as they were over here. So you do get the same answer. The second method also is really helpful in some of the other problems, the last two examples that we're going to do. Okay, the second part of this problem, we have g of f of negative 1. So I'm going to use the second method. I'm going to plug negative 1 into f, and then get an answer and plug that answer into g. So plugging negative 1 into f is called f of negative 1. So I have 4 times negative 1 plus 3. That'll obviously give me a negative 4 plus 3, and when I add those, I get a negative 1. Now I'm going to take that answer and plug it into g. So I'm finding g of negative 1. Well, when I put it in, I want to put it in parentheses, so negative 1 squared, and that means negative 1 times negative 1. Two negatives make a positive. So I get positive 1. And this is my final answer. Now, I have a little bit of a typo here, but this is like sets of points, and so you can use this same method with sets of points. I did mess up on my parentheses. This is supposed to be some version of f of g of x, but I turned parentheses the wrong way and left some off. So we're trying to find f of g of 7 here. So the way we're going to do this is plug 7 into g, get an answer, and plug that into f. So how do we plug 7 into g when we're looking at points? We think back to function notation. Remember that over here when we name functions like f of x or g of x, what's in parentheses is telling us what the variable is. So our variable here is x. When they put a 7 in that parentheses, they're telling us that that is an x value. So I'm looking in g for an x value of 7. So when I go down my row of g points, here I find the x value of 7. My answer is the y value there. So my answer to g of 7 is 1. Now I'm going to take that and plug it into f. Okay, so I'm going to be trying to find f of 1. And again, in this case, the 1 is now in parentheses, so we're now looking at it as it's an x value. And I'm looking down the list of points labeled f. So I go down through there. Here is my 1 in the x value place. My y value for that is 5. So that would be my answer. Now the 5 is the answer to this problem. Lastly, we can do the same thing in graph form. So if you look at this, this is g of f of 2. I'm going to plug 2 into f, take that answer and plug it into g. Now again, this 2 is in that parentheses representing an x value, and again you see the x is in parentheses down here. So 2 is an x value that I'm going to plug into f. So the f is the green equation. X is 2 right here, so I find that point. So I'm looking right here on f. The y value is 1. So f of 2, the 2 is the x value, the y value is 1 on the f graph. Now I'm going to take that answer and plug it into g. So I'm trying to find g of 1. So I look at the blue equation or the blue graph, and I look for the point with a x value of 1. So it's right here. And now the y value is 4. So g of 1 is 4, and that is my final answer. 4 is my final answer. And that concludes this lesson.